Okay. In the last class, we're just discussing network fundamentals. So today we discuss basically Junos operating system or Junos operating system architecture. So as like Cisco use their iOS or operating system. As like Cisco, Juniper also use the operating system on that on their devices. It's maybe router, it's maybe switch, or it's maybe firewall. Okay, so just it's a very basic discussion about Linux operating system. In this course name is NCI Junos, and in this course we will discuss the different topics. Just see here the Juniper products, architectural components, user interface options, configuration task, and last one is firewall filters, routing policy. So this is the topics which is covered under the course basically. So here anyone can join this course who have knowledge about TCP/IP or IP addresses. They can join this course. And this course level is basically this is the introductory course or it's a associate level course. Okay. There is no basically any prerequisite, but if you have knowledge regarding or about OSI model, about TCP/IP protocols, with about IP addresses and basic internet working, that will be help for this course basically. Okay, this is just a course introduction, right? Then I just go to this module, Junos operating system. In Junos operating system, just before starting this slide, I just start my ABNG lab. Okay. We're discussing about Junos operating system. So Junos operating system is basically comes from Linux. This is called FreeBSD. That is one of the Linux distribution. Okay, if you operate in Linux, every segment or every daemon is running individually. So as like Linux, Junos also run their services, run their services using the just tracking the individual resources. One daemon will not interrupt with others. If you have problem in one daemon, other daemon will be run smoothly. So this the just you can say the better design architecture of Juniper operating system. See here, I just write some key point. What is considered in Juniper operating system? Okay, so Junos OS is the single operating system that powers Juniper broad portfolio of physical and virtual networking and security products. Here, say Juniper provide the network devices, and that will be it's a hardware. Uh, mm, uh, I mean, it's a physical device, and also they provide virtualized device. Okay, it may be firewall, it may be a router. So every product use single operating system. Every product use single operating system. They have three type of device. One is routing, three three is the major, but they have also other products also. One is router, another is switch, and third one is security device, that is called firewall. All three devices use same operating system. But if you see the Cisco, if you see Cisco security device configuration syntax is different. Different if you compared with router. If you compared with router, if you compared with Swiss. So this is you can say the benefit of administrator. Benefit of administrator, they just learn one simple operating system and they can operate three different devices: router, switch, and firewall. So you can say one was network wide. One was is used for handle router, switch, and also firewall. That basically reduces the complexity of network management. Administrator need not to learn to operate, need not to learn separately to operate security devices. If just consider, you just want to configure BGP routing in your Juniper devices. If this is Swiss, the syntax, configuration syntax, if it's a firewall, if it's a router, in three devices, your configuration syntax will be same. Okay, that's why we can say this single operating system reduces the complexity of network management. And second one is modular software architecture. So one process cannot directly interfere with another because it's coming from Linux. Linux also have no dependency with the daemon with other daemon. Okay, this is the another benefit of Junos operating system. Another one is you call the high availability. High availability means you can upgrade your operating system. You can insert your card very easily. Just hot swap. Okay, just hot swap. No need to shut down, no need to power up your device. Okay, and then meaningful configuration hierarchy provides an intuitive configuration hierarchy, improves the ability to annotate the configuration. In if you see the configuration perspective, in configuration perspective, there is different option. When you see the lab, they use the different option, which is very flexible for administrator to operate any network. So this is the feature of Junos operating system. Then this is second part of operating system of Junos. Just routing policy management. It's very simple. You are just making decision in respect to routing protocol. You can make the policy. This policy you can apply in different routing protocol. You can apply this policy in OSPF routing protocol or in BGP routing protocol. This this routing policy language is same. No difference in router, no difference in security devices. Same policy will be applied there. And you can say another feature is disaggregation. Enables more flexible licensing consumption model for network application, enable DevOps approach. You can know the concept of DevOps, and you can also know the automation. So this device is capable. You can add this device in your automation environment. Okay, and licensing is very easy way. You can easily upgrade the license of your boxes. It's maybe hardware or it's maybe virtualized devices. Open and programmable automation, I already discussed. This is capable all devices. It can be switches, it can be router, or it can be security devices. You can deploy these devices in your automation environment very easily. They learn. You can deploy off-box automation. You can deploy on-box automation. Okay. See here. This is just see it's a switching. It's a switching device. And naming convention will start with EX. This is a security device that just naming convention start with SRX. This is a router and naming convention starting with MX. 2010 it's a model. 300 it's a model number, and 2300 it's a model number. Okay, and this is the version number basically. Now starting version here showing 20 point something, and now ending version is 21 point something. So our you can in your production you can say less than 20 version, software version is maybe less than 20. That means this device is basically more older than current time. So one was network wide this concept. Juniper used this concept. So for using this concept, a single software trained for all platforms running Junos OS. It is management overhead by providing consistent set of features that are implemented in a consistent manner. This is the very useful feature of Juniper devices. The most common types of release is the R release. R means R means it's a basically when release the software, they have naming convention. Their naming convention is like this: am.nzb.s. So what is the meaning of the character or letter? am.n means main or minor release numbers. M means minor release number. Main and minor release number. Z means release type, B means build number, and S means speed number. Basically, in Juniper operating system, they will produce two separate operating system, one for just for beta version, and another one is called the bug fix version. And just see here, Juniper operating system, another feature, the feature is modular software architecture. Every daemon, every daemon and every services is running individually. They are not dependent with other daemon. So this feature is called the modular architecture feature. This modular Junos OS architecture provides highly scalable software that keep pace with evolving requirements. If you see my lab, just mm, says from 192.168 admin deep security lab. Just close this one. JNCIA Junos December 23. This is your lab. You just set your name VMX1. It's a router. There's 8 interface, 2 GB of RAM, and 1 CPU. Just run this device. Start. This device now just complete the booting process. So go to the slide and then come back. So modular software architecture, if you just working in Linux, you can just um, place some CLI command to see the overall resource uses of your system. It's a very similar task executed in our Juniper devices, show system process extensive. This command just show you the output of different daemon uses. This is the management daemon, packet forwarding daemon, RPD, routing protocol daemon, SNMP daemon, chassis daemon, management daemon. So there is the daemon name and there the process uses. What is the percentage of uses of the daemon? So every process here taking uh, local resources like RAM, like disk, like CPU, individually from physical boxes or virtual boxes. And there have another fantastic feature, which is basically deploy in initially separation of control and forwarding plans. You know the concept of control plan, what is the control plan and what is the forwarding plans. So control plan is just you consider if you configure a routing protocol, just consider you just deploy or configure one routing protocol. This is your router connected with another router. This three router is connected with this other R1, R2, and R3. Your connected source is here. This is source 1 and this is destination 1. If I send packet from source 1 to destination 1, there is two paths. Number 1 is this and number 2 is this path. There is two paths to reach the destination. So what will be the best path? Who select this? Routing protocol. Routing protocol select the path. Which one is the best? Okay. So this routing protocol decision will make in control plan. Will make in control plan. If anyone goes down, another path will be the best. That also comes from control plan. But if you consider the forwarding plan, what is the forwarding plan? In forwarding plan, you see the source is connected with R1. Just a minute. Sorry. Okay. So we're discussing the difference between the control plan and the forwarding plans. So if control plan, these two plans completely different. If you see the forwarding plans, they have maintained the forwarding table. They have maintained the forwarding table. Based on routing protocol, this source is connected with router 1 and this destination is coming in router 1 through any routing protocol. So this router maintain one single routing table. This routing table, there have two routing table. One is RIB and another one is FIB. Number one, RIB means routing information base. Another one is FIB, forwarding information base. So there is two path. Only one path will be the best. One path will be the best. So as per routing FIB, as per forwarding information base, Just look, this is the incoming port, and this is just if you consider this based on routing protocol or based on A5B, this is the incoming port and this is the outgoing port. So based on forwarding table, this packet just coming in this port and outgoing through this interface towards the destination. So they are not interfacing the router CPU or router control plane. So if the control plane and forwarding plane function separately, this router handle more traffic. The router handle more traffic. That's why Juniper divided the plane in two types. One is control plane, another one is forwarding planes. So see here, all platforms running Junos OS share a common design goal. All platforms maintain this goal. Control plane and forwarding plane is different. Clean separation of control and forwarding functions enables Junos OS to support many different platforms from common mode. So Juniper, basically all devices, it may be router, it may be switch or firewall, maintain this format. Control plane and forwarding plane must be separate. Just see the details of control plane and forwarding plane. What is happened in control plane? Just see here what is happened. Control plane is you can say maintain the routing engine basically. In control plane, Juniper operating system maintain routing table. So routing table, how to make this one routing table? Basically, routing table makes from the routing protocol or routing information sources. You have one router. Uh, this router have multiple routing protocol, and from this multiple routing protocol, router making a routing table. From routing table, they just from routing table comes forwarding table. Forwarding table comes from routing table. Okay. So what is the difference between forwarding table and routing table? Forwarding table, all the base path is in forwarding table. But in routing table, the all available paths will be in routing table. But forwarding table, only base path. Only base path. You can say bracing table for layer 2 perspective. You can say routing table and forwarding table respect to layer 3. So the difference between routing table and forwarding table is maintained by routing engine, that is called the control plane. Routing table, for just making the forwarding table from the routing table, this also happened in where the control plane. There is a implicit link between routing engine and packet forwarding engine, or you can say control plane and forwarding plane. There is the internal link. This link basically used to controlling unwanted packet, which is maybe interfacing your routing engine. Okay. So see here the feature routing engine, brain of the platform, and is responsible for performing protocol updates and system management. So routing engine is the brain of this Juniper operating system, and runs various protocol and management software processes that reside inside a protected memory environment based on 86 on PowerPC architecture. That means 64-bit architecture. So just see the packet forwarding engine. In packet forwarding engine, there I have layer 2 and layer 3 forwarding tables. Layer 2 and layer 3 forwarding tables is in forwarding plans. Just frame or packets coming in incoming port, checking the forwarding table. It's maybe layer 2, it's maybe layer 3. If layer 2, considering frames. If layer 3, packet considering in packets. Then, based on forwarding table, packet goes to outgoing port. This is called the forwarding plan. Okay. Separation. High availability features such as graceful routing, engine switchover, non-stop active routing, unified in-service software upgrades can be included in this design. Just if you see in forwarding plan, if you just enable, you just update your software. You just want to update your software. You have a router that have two routing engine. If one routing engine software upgraded, mm, don't update in another routing engine. Just consider here. This is uh, this is your router, higher end router basically. There is multiple routing engine. This is routing engine 1 and this is routing engine 2. Routing engine is the brain of the these boxes. So if routing engine 1 failed, automatically your all services, all protocol configuration will move to routing engine 2. So you want to upgrade your Junos operating system in routing engine 1. If you want manually upgrade, you can just upgrade routing engine 1 operating system, then upgrade routing engine 2 operating system. If you dynamically upgrade, just upgrade one routing engine, automatically upgrade another routing engine. If you want this feature, we need to enable this one. Unified in-service software upgrade, non-stop routing, and routing engine switchover. All these three features needed to getting this benefit. So all the three steps happened in forwarding plans. All are happened in forwarding plans. So, again, see the routing engine. What is the basically they perform the three main tasks. Routing engine perform basically three main tasks. One task is maintain routing, that means routing protocol or routing table and the forwarding tables. Controls and monitor the chassis and manage the packet forwarding engine. These three are the main tasks of routing engine. And what is the task of forwarding engine? The forwarding engine performs basically two main tasks. One is layer 2 and layer 3 forwarding tables provided by routing engine to forward traffic toward its destination. And another one is in forwarding table, we can apply polyser, we can apply stateless firewall and class of services. So forwarding engine basically maintain forwarding tables, number one. Second one is maintaining polyser, stateful firewall or polyser firewall and class of service. This So this is just a question and answer section. Who is of the following are advantages of Junos OS? This are the three main features. New features can be added without affecting current functionality. Just you need new feature is coming. Consider new feature is coming. You need to add this feature in your boxes. So without interrupting other features or other daemon, this can be added. Junos OS runs on a modified and hardened version of either FreeBSD or Linux. Junos OS process run in a protected memory space, ensuring that one process cannot directly interfere with another. Okay. So, which two services are implemented by Junos OS? So, which two services are implemented by the Junos operating system packet forwarding engine? Packet forwarding engine, we see here firewall class of service. So, in question answer section, could you anyone say what is the difference between routing engine and forwarding engine? Anyone? What is the difference between routing engine and forwarding engine? Anyone can share? Hmm. Okay, carry on. Hello. Yes, yes. Please continue. Your sound is very slow. Could you more could you more louder? Yeah. Yes. Just increase your. Yes. Yeah. Yes. Yes. Mhm. Basically, maintain just forwarding table. Okay. Good. Thank you. So last question number 3, which component is responsible for performing protocol updates and system management? Protocol updates happened in routing engine. Okay. So there is if you divide or if you see our traffic pattern in our internet or in our network. Traffic will be two type. One type is transit traffic and another one is exception traffic. So what is the meaning of transit traffic? Transit traffic means traffic is just coming in your router and forwarding to outgoing interface to towards the destination. This is called the transit traffic. Just consider your your this is your gateway router, this a router. You use one PC connected with this router. This router is router 1 and here is connected internet. So consider just browsing www.juniper.net. www.juniper.net. Juniper.net is not connected with router 1. This connected with cloud. Okay. So this packet coming one interface and just forwarding another outgoing interface towards the destination. This packet or this traffic is called transit traffic. This traffic is called transit traffic. Okay. For transit traffic, it may be unicast, it may be multicast. For transit traffic, this traffic is not interfering routing engine. It's not interfering routing engine. Transit traffic just check the forwarding table, and forward this packet to the outgoing interface towards the destination. So if you consider our standard internet uses, most of the traffic is the transit traffic. Very little bit traffic is exception traffic. Exception traffic, what is the meaning of exception traffic? Exception traffic means you have just administrator of this network. You just log in this router using CLI or graphical. You just send an ICP packet to your router to checking router is live or dead. So this packet is dropped in router itself. This traffic is called exception traffic. For exception traffic, only CPU is involved to maintain this packet, to control this packet. Okay. So just see here the transit traffic processing. Transit traffic is forward through the local system. Example, maybe you can consider unicast traffic, you can consider multicast traffic. Okay. Exception traffic processing. So just send here one packet, and this is no desired basically desired destination not in packet forwarding engine. That means FIB forwarding table. This packet is handled by routing engine. So exception traffic, when exception traffic is coming in the router, exception traffic is processed by the local system also, but the pattern will be different. Traffic destined for the local system is processed by the routing engine CPU. In most cases, the packet forwarding engine process traffic requiring the generation of Internet Control Message Protocol. This is called the ICMP message, such as time to live expire message. You can see the routing protocol update. If you just configure to router, you just consider you have two routers connected with each other. You configure here OSPF routing. So in OSPF routing, they are just sending and receiving routing update. This routing update also maintained by the routing engine or control plane. Okay. So if a dynamic routing protocol is configured between router 1 and router 2, they are sending and receiving the hello packet. If you configure the OSPF, they are sending hello packet, receiving hello packet. If you configure the BGP, the keep alive message will send and receive. So this routing protocol updates, this called the routing protocol updates, also handled by the routing engine. And this packet is called the exception traffic. This packet is called the exception traffic. So exception traffic is rate limited on the internal link. This is the internal link between packet forwarding engine and routing engine to save or to protect the routing engine. You also know the DOS or DDoS attacks. So if just DOS or DDoS attacks is coming in routing engine itself, they this traffic will be built-in rate limited. This traffic will be in built-in rate limiting. So this built-in rate limiting, you can't modify this. You can't modify this. So this concept basically very helpful for a hardware or a router or your network devices. So this type of packet will be handled by the routing engine. So this is the basically difference between exception traffic and the transit traffic. So could anyone tell me the difference between exception traffic and transit traffic? What is the difference? Anyone? What is the transit traffic? What is the exception traffic?
Transit traffic is between two carriers, and exception traffic is as a routing protocol such as OSP or BGP.
Yes, routing protocol message or routing protocol packet. Or you just log in your router using any graphical window like JWeb, or you can log in your router through SSH or Telnet, or you just send a ICMP packet to checking your router is live or not. So all are the exception traffic. Okay, so perfect. And this is basically the architecture of modular architecture of Juniper operating system in both. Is it using quality of service? No, this is quality service concept is different. Different quality of service concept is different. Okay, we are just discussing about transit traffic and exception traffic. Quality of service, you just push just you can set some quality feature, or you can just prioritize your traffic. Then you can consider the quality of service. Okay, so in Junos software, we already know this is the modular software, and this software we can deploy this software in the hardware boxes, also the virtualized VM, that means VM. In Juniper devices, if you see the product line, they provide hardware, also the VM. So if you consider this is basically historical background of Junos OS. This is the basically just starting 1990 to 2012, 1919 to 2012. This is single Junos operating system, and this is basically based on hardware. No virtualized environment is deployed in this direction. After this, 2012 and 2016, that applied the VM based, also hardware based Junos devices. After that, this is the upgradation, distributed state infrastructure, And here the s- separate daemon, all daemon is separate with each other. So this is the basically starting to ending Juniper operating system history. Okay, this is the another picture. This aggregated Junos operating system. Here is basically the same concept. They basically produce different different product. Like product name is NFX series devices, TX series devices, MX series devices, modern devices. They are just what is modern devices. The advantage of this aggregation, disaggregation advantage is this is the key point basically. So removing the platform drivers and forwarding engine from the control plane image, running them in the another thread improves the control plane performance significantly. And Junos OS virtual machine, that means VM, is hardware independent and focused on the control plane only, speeding up the innovation process. This all the feature of disaggregation of the software. Just see the last one. This is 2018 plus. Here they consider based on operating system, code in self-contained application, a high horizontal and vertical scale, application level, high availability, fine-grained and pre-facility telemetry, model-driven API and software, support of third-party software. This operating system also included AI. If you see the product line of wireless devices in Juniper, they introduce AI, they introduce machine learning. Okay, so here is the just question and answer section. What is the transit traffic? Just see here, transit traffic forward through the packet forwarding engine on platform running the Junos OS based on forwarding table. Transit traffic is handled by the forwarding engine. What is the exception traffic? Exception traffic is handled by the routing engine. Protocol and management traffic. Protocol and management traffic. Protocol and management traffic pass directly to the routing engine for processing, while traffic requiring ISMP error message response is typically handled by the packet forwarding engine. This is protocol and management traffic. But routing protocol traffic is basically handled by the routing engine. So the question is, what is required for a Junos OS device to successfully forward transit traffic to the destination? For transit traffic, we need forwarding table. No need the basically the routing table or other these things. So Juniper hardware products overview. Now we discuss the different devices of Juniper operating system. It may be a router. It may be multiple device produce the Juniper. Okay, so see the this is switching device, this is routing device, this is the security device. Main is three. The main three type of networking device produce the Juniper: switching, routing, and security. Switches, routers, and security devices in large and small networks. That means they have different version, different in series. They based on our network infrastructure. Our network infrastructure may be different. It's uh, a small office, home office, or it's a medium range network or campus network. It's maybe large network. Okay. So based on your design, it will basically fill up your requirement. Junos routing devices. For routing purpose, Junos operating system or Juniper provide different type of series or different series of product. One is SX series, another MX, and last one is PTX series. Basically, ACX and MX series is required for mid-range organization. And PTX series is the this is a very heavy router, and this router is basically deployed in service provider grade. Okay, so this is the SX series. SX series products deliver simplified end-to-end provisioning and support layer 2 and layer 3 functionality with IP or MPLS traffic engineering. This is the feature. If you see the MX devices are basically these devices throughput, and others is basically MX series device. You can get a lower model or you can get the upper model. Based on your network infrastructure, you can choose. Okay, so see here, MX series Ethernet services router provide up to 80 Tbps. 80 Tbps. Okay, if you go to PTX series handle 460.8 Tbps throughput. Means they handle 460 Tbps traffic at a time per second. So Junos OS switching devices. So switching devices basically they produce two series. One is EX series and another one is QFX series. EX series is basically deployed in enterprise network or campus network, and QFX series is basically deployed in data center. In EX series, just see here, they provide the 13.2 Tbps throughput. And if you go with QFX series is more than this. And they have multiple port combination like 10G, 25G, 40G, 100G, or 400 GB SFP module or SFP port. This is the security device of Juniper. This is only one series. This SRX series. SRX series is used for basically firewalling. SRX series device is called the firewall appliance or firewall devices. There have some lower model, there have some upper model based on your topology. If this is deployed in data center, that will be you should choose the upper model. Okay, Juniper security products and another products product line is next generation firewall, JATP series, Sec Intel series, DDoS protection series. Okay, so next generation firewall services, advanced application visibility control, user and role-based policy, nested application support, up to just secure your network up to layer 7. Juniper security products, ATP cloud, and JSS series. All devices are used to secure your network. If you just consider the Juniper devices. Juniper security products, Juniper also basically provide the virtualized device. You can deploy your device not in here. VSRX. This is called the VSRX. This is the virtualized SRX. You can deploy this SRX in your virtualized environment. It's maybe KVM or other virtualization like VMware, VSXL like this. Okay. Juniper CP devices. CP devices is called the customer premises equipment or customer premises. That is called, you can say, the our home device. Our home device means a small office, home office device, Wi-Fi router like these devices, CP devices. Or Juniper also provide wireless access point with cloud. You can take a controller as a appliance, or you can take controller from the cloud. This is the access point of Juniper devices. Basically, we use access point to connect our end device through the wireless. So this is called the wireless device. They also produce IoT devices. this access point. And Juniper always applies controller and other device is maintained by the Juniper Mist Cloud Services. Mist Cloud Services. Okay. If you compare with Cisco, so Cisco also provide their hardware controller, or they have also the cloud version also. So this mist version of Juniper, that is the world most renowned version, most renowned version of the wireless section. Okay, so this is the this cloud services. Okay, that this is the answer question answer section. Just Junos switching device, AX series and QFX series, and routing devices PTX, MX, ACX, like this. And security devices SRX, ZATP series, JSS series, and Juniper wireless AP devices is AP series, BT series, Mist S, like this. Okay, just read this name. And this basically will be helpful for when facing any interview. They are just asking, so tell the some series or tell the some device name which you know. Okay, Juniper software products. If you consider in respect to software as a virtual device, you just deploy your hardware device as a virtual infrastructure, as a virtual device. You just you have a virtualized environment which is running through Proxmox, or it's maybe running through VM or ESXi. You just deploy your router as a VM, security device as a VM. You need the just take software from Juniper. If this device is SRX, just purchase the software of the SRX, and you can deploy in your virtualized environment. Like SRX, you can also deploy VMX. You can also deploy VQFX. V means VM. V means here. V means VM. This also deployed in VM. Okay. Or you can also deploy the Juniper operating system. You can also deploy the Juniper operating system in your container. In your container. Container also, you know the difference between VM and container. Container is the basically little version of VM. Basically, little version of VM. Okay, so if you need the less resources, less requirement, then you can choose container. So you have option. You can purchase hardware, you can purchase software. If you purchase software, you can deploy it in VM, you can deploy it in a container. These are the three options you have. So you choose which is perfect for your topology, for your infrastructure. Okay, Juniper also provide SDN products. So SDN products is called SDN product is Control Cloud, Control Networking. These all are SDN products. You know the SDN is software defined network. For software defined network, Juniper produce these devices to maintain the SDN. This is the basically SDN products, Control Cloud and Control Network. Juniper SDN products. Juniper network management products. If you if just consider you have maintained Okay. So consider you just maintain a network. It may be campus network or it may be enterprise network. So in a enterprise network, you have multiple devices. Have multiple devices. You have switches, you have router, you have security devices. So if you have a network management system, if you have a network management system, whose network network management system just show you all the devices in single window, all the devices in single window, and you can access the remote devices through the NMS, network management system. This network management system, Juniper, is called the Junos space. Junos space is the network management platform or network management system which is provided by Juniper, which is provided by Juniper. This platform just simplify the automated management of Juniper routing, switching, and security devices. Provisioning new services, optimize workflow tasks across thousands of Juniper devices. You just configure some task thousands of Juniper devices. So if you have the Junos space, that is very easy to deploy. Okay, and another one is the Sky Enterprise. So Sky Enterprise is designed to abstract, simplify, and hide network complexity from branch and campus net customers. As network administrator and costly, eliminating the software maintenance cycle and dedicated network management in infrastructure. Basically, Junos space is very popular in Juniper operating system to maintain your Juniper devices in a single window. And this is Juniper automation portfolio. In Juniper automation portfolio, they are providing the automated infrastructure. You have just consider you are a executive engineer, or you are just a network engineer of large enterprise network. So there have thousands of devices. There have thousands of devices. Just consider you have just configuring some applications, software applications. It's maybe DNS, NTP server, FTP server. So this information will be configured thousands of Juniper devices. So if you just consider the automation perspective, it's very easy to deploy the configuration. It's very easy. But if you manually do, if you just want to do manually, it's you can say it's a resource. This take more resources, more time. So to just you want to reduce resources, you want to reduce time, so you have to go with automation. So Juniper devices, and they have just Apistra 128, and this three combination of devices to complete the automation of Juniper devices: Paragon, Planner, and Pathfinder. Basically, these two devices is Apistra, Juniper Automation. Apistra intent-based system, AIS software for data center networks to easily automate, manage, and monitor your data center fabric, simplifying day zero through date operations. AIS automates all aspects of network design, build, deploy, and operation phases. 128, that this is called basically session smart router. User-centric SD-WAN delivers game-changing insight automation from client to cloud. So simply just you think you have lots of devices in your network. If you deploy some if you configure some line, all your infrastructure devices, so that is very time consuming, that will take more resources. If you go with automation, that will be perfect. This is the question answer section. So these are basically all for today's. If you have any question based on last class and today's class, you can ask me. Anyone have any question? Okay, no question. Just I go my lab. See here, I will show you the multiple demo session appearance. Well, default user is row and password is row 123. This is the shell prompt. Percentage is mean the shell prompt. If I place a CLI, I just here operational mode. In operational mode, we just execute the show command. We just execute the show command. If I changes any configuration, you have to go the configuration mode. Edit. Edit is called the equivalent of CD in Linux distribution. See here, multiple daemon. One is routing daemon, security daemon, SNMP daemon, Swiss daemon, system daemon, firewall daemon is the chassis daemon, completely in separate line. Completely in separate line. Okay. So next class, I will show you how to configure just initial or basic configuration of Juniper router, how to configure that means basic configuration, how to set the host name, how to set the IP addresses or related parameter, how to set the time zone, how to make communicate with another host, how to check the communication or connectivity. Okay, what is the demo? Yes, I will. Yes, you will get the EPNG. That means Juniper OS image. What is daemon? Daemon means service. Daemon means one service. Like this is your router. This is your router. This router maintain this router maintain the routing protocol. This router maintain routing protocol. They also provide the security function. They also provide the system function. So if I consider protocol, protocol is responsible protocol is responsible for different routing protocol. It's maybe WSPF, it's maybe PGP. So this protocol is running individually. Individually, this protocol you can say running under routing protocol domain. This protocol is running under routing protocol domain. You can say also it's a service. Daemon is equal to service. There is multiple service or multiple application running in your boxes. Running in your boxes. So daemon is called the service. You can say daemon is called the service, or daemon is equal to service or application. Clear? Okay. Any other questions? I think next class will be more interactive. Next class, basically, I will show the lab. Today, most of the part is the theoretical. Basically, this it's a introductory course or associate course. That's why one to class it's based on theory. Basically, we continue theory. If there is no question, any question? If you have no question, we can close now. Okay. Allah Hafiz. Assalamu alaikum.